right, number 19. We want to circle the shapes below that have both line symmetry and point symmetry. Now, point symmetry is the same as rotational, where you grab it in the center and can it spin and land on itself before you spin it all the way around 360 degrees. So let's take a look. We have the circle, rectangle, isosceles trapezoid, square, scalene triangle. Remember, a scalene triangle is a triangle where none of the sides are the same length, is what that's going to be. Let's go to what I have. Let's start with the circle. Okay, so let's go to the circle. Does it have line? Well, yes, we go right through the center. As long as you go through the center, no matter what line, that was not through the center, but it is going to flip on itself. So we know it has line. And it obviously is going to have rotational because if we grab it and spin it, it just lands on itself every millionth of a second, right? So that guy does have both. So a circle, we're going to say, hey, yes, sir, it does. The next, okay, a rectangle. Well, we can see, yes, down the center, it has horizontal, it has vertical. So it does have line. Does it have that? No. Remember, the diagonal is not there. Just want to point that out. But it does have line symmetry because, yes, it has horizontal and vertical. Now, if we grab it, okay, so we're going to grab it and we're going to try and spin it. Does it land on itself? Not yet, not yet, not yet. But after 180 degrees, it is back on itself. So, yes, it does also have, whoops, change back to the pen. It does also, the rectangle has both line and point. To the next picture. Ooh, an isosceles trapezoid. What about this guy? Well, it doesn't have any horizontal line, does it? But it does have a nice vertical line where it'll land on itself because that angle's the same as this one. So they'll land. He's the same as this one. It'll land on itself. So yes, it does have line, but what about rotational? Does it have rotational? Well, let's grab the thing. I think you can see it doesn't because as we spin, no. Now I've spun it 360 and it's back. So the answer is no. So for this, it's no. It has line, but it doesn't have both. Let's go to the next shape. Well, next shape is a nice, beautiful square. Yes, we know it has it horizontally, vertically, diagonally. It does. And will it spin and land on itself? Well, again, I think we should be able to see it. Grab it. Oops. Let's try to grab it and spin it. We start spinning. I spin 90 degrees. Boom. It's right on itself. So yes, it has both for this. So a square has both. Finally, a scalene triangle. A scalene triangle. So that's a triangle where none of the angles are the same. Yeah, it doesn't even have line symmetry. So that's not going to do us any good. Okay. No matter where I draw the line, it's not going to, because all the sides are different lengths also. So we're just not able to make it land on itself no matter how we cut it. So that's going to be a big no. If we take it and try to spin it, we should see also that that's not going to work because as we spin, it just doesn't ever quite land back on itself until you go a whole 360 degrees. So this one is going to be a big no too. So you're going to circle square, rectangle, and the circle. Those have both line symmetry and point symmetry.